video, we're going to look at the area of a trapezoid. Just like with parallelograms, we want the formula to come from reasoning, not just memorization. Let's consider these different trapezoids. And even though these look different, we can use the same general idea for all of them. We want to take one of our trapezoids, and I'm going to start with the right one, and place a congruent copy next to it, rotate it so that they fit together to make a parallelogram. And we can do this for all of these trapezoids. We can take two copies and flip one and fit them together to make a parallelogram. This is a really nice geometric move. Instead of trying to find the area of one trapezoid directly, we combine two trapezoids into a shape we already understand. Now, let's think carefully about the dimensions of this new parallelogram. The height of the parallelogram is the same as the height of the trapezoid, which we called h. What about the base? The base of the parallelogram is the sum of the two bases of the trapezoid, b1 plus b2. In both this one on the left and the one on the right, the top has a b1 followed by a b2. And the same thing on the bottom, we have a b1 as well as a b2. So, since it takes two trapezoids to make our parallelogram, we would then need to half this so that we get only one of our parallelograms. So, the area of our trapezoid would be 1/2 b1 plus b2 times h. This is sometimes thought of as the average of the bases times the height, because 1/2 of the sum of the bases is the average of the two bases. That interpretation can be helpful to students. It tells us that the trapezoid behaves almost like a rectangular parallelogram, whose base is halfway between the two base lengths. Let's connect this back to the pictures. For the right trapezoid, the first one we have, it may be especially easy to see how two copies fit together. For the isosceles trapezoid, the middle one, the symmetry can make the parallelogram especially satisfying. For the irregular trapezoid, the one on the right, the shape may look less familiar, but the same reasoning still works. This is a great reminder that formulas depend on defining properties, not on whether a picture looks nice. A useful teaching point here is that students often need help identifying the two bases of the trapezoid. The bases are the parallel sides, not just any two sides that happen to be on the top and the bottom in a drawing. This is another place where language matters. Beautiful work. This is another example of geometry helping us build formulas from ideas we already know. This is exactly the kind of reasoning we want students to experience. In the next video, we'll step back and look at the relationships among quadrilaterals, including the classic question, are squares rectangles?